Hello everyone and welcome back to another problem of the day, and today's problem is titled Maximum Selections. In this problem, you are given a finite number of courses and n range of numbers, each depicting bundle of courses, and your job is to select the maximum number of bundles such that no courses overlap in any of the bundle. And they have also given a note that the ending of a range being the same as start of another isn't considered as an overlap. So this is what we have to consider. And for the first example, with four ranges, that is 1 2 5 2 3 1 8 and 3 5, we have the output as 2. That is nothing but they have considered the range 2 3 and 3 5. As you can see, 3 here is the ending and beginning of the ranges respectively. Since it is the same, we can conclude those two pairs to be non-overlapping, and that is how we got the answer to be 2. And for the second pair has n equal to 5, and we have the following ranges, and for this the output is 3. So let's have a look at this example. So for the second pair, we have the bundles as 7 9 2 8 1 3 10 11 10 16, and they have represented it using the range from 1 to 16, and they have marked it accordingly. Now if I consider the first range, that is according to the bundles 2D array, that is 7 9 and 2 8. Here 7 9 is the beginning of the range and 9 is the ending. And if I consider the next one, which is 2 and 8, now if I have to conclude these two as either overlapping or non-overlapping, then one of the checks I'll have to make is that if I'll have to check if the beginning of this range, that is 7, if it lies in between 2 and 8. Yes, it does. So I can simply conclude that they are non-overlapping. Similarly, if that was not the case, let's say 7 was this particular range was starting with 1 and ending at let's say 7. Then in that case, if I check 1 with 2 and 8, it's not present within the range. But then I'll again have to check if this particular value, that is 7, if it is present between 2 and 8. Yes, it is. Then again we can conclude it as overlapping. So I'll not be including the pairs, or I'll only include one of the two pairs. Now, if since there is no particular order to the bundles given over here, if I had to count all such ranges, then I would have to make a check with each of the pairs given. That is, I'd have to make a check 7 9 with 2 8, then 1 3 10 11 10 16, and that would simply contribute to our increasing time complexity. And that is not what we want. Since they have told us that we can solve this problem in O of n log n time, there must be some other way to solve this problem. So one thing that we can do is we can simply sort the ranges of the bundles in increasing order of the end of the numbers, end of the ranges. And using this, I'll be able to have the minimum ending point at the beginning and the highest ending point at the last. So what is the use of that? So let's first sort them. So if I consult this bundles array, the first element to appear would be 1, 3. Next one would be 2, 8. And the one after that would be 7, 9. Next one would be 10, 11. And after that, it would be 10, 16. Now I've sorted them in order of the ending ranges, that is 3, 8, 9, 11, 16. Now, if I have to take in this particular range, I'll take in this particular range. Let's say the number of ranges that I have, let's say the count of that is 1, which is this particular range. If I have to conclude that this particular range is not overlapping with this, what I can do is I can check the ending of this range and compare it with the beginning of the next range. And if the ending here is greater than the beginning of this range, it simply means that these two are overlapping. So I'll not be including this. Now I'll simply take this ending again and compare it with the beginning of this range. Now 3 here is smaller than 7, which simply means that this particular range is not overlapping. So I'll simply increment my count. Now after incrementing, I'll update the ending pointer, the ending to be 9. Now I'll compare 9 with 10 over here. Again, 9 is smaller than 10, means they are not overlapping. So I'll again increment my count. Now again take in this 11 and compare it with 10. Now comparing 11 with 10, I simply find out that here 11 is greater than 10, meaning they are overlapping. So I'll not be incrementing count. And I've reached the end of the range, end of the bundles. And I can conclude my count to be 3. Now what if I want to start with 2, 8? If I start with 2, 8, here 8, I'll compare 8 with 7. Again, 8 is greater than 7, so my count remains as it is, that is 1. I'll compare 8 with 10 over here, and since 8 is smaller than 10, I can increment my count and I can update my end pointer to be 11. Now I'll make a check for 11 with the next range's first value, that is 10. Again, since 11 is less than 10 over here, I mean greater than 10, so will not be including that range. And now here my count is 2. So as you can see, if I start with the first, if I start with the first range itself, I'll get the maximum value. This is because we have sorted the ranges according to the ending value. So it would not make any sense to start with the next range and start the comparing again. This is because we are following a greedy approach, and a greedy approach for this particular problem is the best possible solution. In order to understand this better, I suggest you try on some other examples and do a dry run of this particular approach for those examples. Then it will be much more clearer as to how and why this greedy approach always works if I take in the first minimum value. So let's jump right onto the code. So first of all, I'll have to basically sort the ranges. That is what we discussed. So I'll be sorting my vector, that is ranges dot begin, ranges dot end, and I'll make use of a comparator to compare the end values and sort them accordingly. So let's call it CMP and we'll define it over here. It will return a boolean value. All right, and we'll be passing in our the two values of our vector, that is nothing but vector, the first value, let's call it A, and the second value, let's call it B, and I'll return A of 1 if it's less than B of 1. So after sorting, I'll create a variable, let's say count, and I'll be storing 0, and also create the ending value variable, wherein we'll be storing the ending value of the last compared value. So let's initialize it to -1 because we'll be starting from the first position and there's no range behind it, before it. So we'll be starting off with -1 and we'll compare as and when we go and update our ending variable. So we'll loop over our range. So yeah, ranges. Now we'll make a check. We'll make a check if the ending of our current well, since we are starting with -1, since my ending is marked by -1, I'll make a check if the ending value of the current range, if it's greater than, if it's less than the beginning value of the next range. If that is the case, then I'll simply increment my counter. So if the ending value is less than or equal to, since we can include the ranges with the same start as the next one, same ending as the next start. So in that case, we'll be using less than equal to, and we'll make a check if it is the ending is less than equal to the range 0 value. And if it is, then we'll simply increment our count. After incrementing, I have to update my ending variable, the current ending, which is nothing but r of 1. And using this, we'll be able to loop over and get the count of the range of the ranges that we can include and return the result, which is nothing but count here. So let's try and compile. All right, CFT. Invalid use of non-static. All right. All right. So that was it for today's video. If you have any doubts or suggestions, you can ask them in the comment section. And thank you for watching.